Welcome to Black Hole Basics. Today, we explore our magnificent sun. Look closely at this boiling ocean of hot plasma. Every single second, this giant star releases terrifying energy that is perfectly equivalent to billions of nuclear bombs detonating together. This colossal explosion happens continuously in the dark void of space, creating a beautiful yet incredibly violent celestial spectacle above. To truly understand this massive cosmic engine, we must journey deep inside its mysterious and complex internal structural layers now. We will dive far beneath the blinding surface, traveling straight toward the absolute center, where the ultimate magic actually happens. Welcome to the solar core. Here, the crushing pressure is unimaginable, reaching levels that defy our normal human comprehension completely. The temperature in this extreme central region soars to a staggering 15 million degrees Celsius, melting everything into pure plasma. Under these brutal conditions, ordinary physics takes a drastic turn, forcing atomic particles to behave in very strange new ways. Hydrogen atoms, moving at incredibly blinding speeds, violently crash into one another despite their strong natural magnetic repulsive forces here. This intense collision causes them to fuse together permanently, forming a completely new and heavier element called helium gas immediately. This spectacular process is known as nuclear fusion. It is the fundamental secret behind the endless power of our star. During every single fusion reaction, a tiny fraction of physical mass mysteriously disappears from the newly created helium atomic nucleus. Where does that missing mass go? It transforms directly into pure energy, following the brilliant mathematical equation of Albert Einstein. The formula E equals mc squared perfectly explains how a microscopic amount of matter creates an absolute radiant mountain. Every second, 4 million tons of solar matter are completely annihilated and converted into pure light and heat radiation forever. This newly born energy begins its long and difficult journey outward, starting as highly energetic and invisible gamma-ray photons. Leaving the core, these photons enter the massive radiative zone, a dense layer that severely slows down their outward escape. In this incredibly crowded space, a single photon cannot travel in a straight line toward the distant outer surface layer. It constantly crashes into densely packed particles, bouncing wildly in completely random directions, like a trapped pinball bouncing around endlessly. This chaotic movement is famously called the random walk. It makes the outward journey unbelievably slow and terribly frustrating indeed. Because of this endless bouncing, a single photon can take hundreds of thousands of years to finally cross this zone. Think about that incredible fact. The warm sunlight hitting your face today was actually created long before modern humans existed. It is truly ancient light, born in the deep darkness of the solar core during the prehistoric age of Earth. After finally escaping the dense radiative zone, the struggling photons enter the next crucial layer called the vast convective zone. Here, the solar material is slightly cooler, allowing massive columns of hot plasma to physically rise toward the upper surface. This creates a violent boiling effect, very similar to a giant pot of water bubbling fiercely on a hot stove. Huge bubbles of superheated plasma rapidly carry the trapped energy upward, while cooler plasma sinks back down to be reheated. This constant churning motion generates powerful magnetic fields that twist and turn violently beneath the visible surface of the star. Finally, the ancient energy reaches the outermost visible layer of our star, which scientists officially call the glowing solar photosphere. This is the bright yellow surface we see from Earth, radiating brilliant light across the cold vacuum of empty space. Even though it is the coolest layer, the photosphere still burns at an incredibly scorching 5,000 degrees Celsius today. Looking closely at the photosphere, you can clearly see dark patches scattered randomly across the bright and burning solar landscape. These mysterious dark spots are called sunspots. They are temporary regions where intense magnetic fields have violently broken the surface. Because these magnetic fields restrict the flow of heat, sunspots are significantly cooler, and therefore appear much darker to us. However, These seemingly calm dark regions are actually the dangerous birthplaces of the most violent solar storms in our system. When tangled magnetic field lines suddenly snap and realign, they release massive amounts of stored energy in huge explosive bursts. We call these massive explosions solar flares. They shoot intense flashes of deadly radiation deep into the surrounding solar system. Sometimes, these flares are accompanied by coronal mass ejections, which hurl billions of tons of electrified plasma into open space. If one of these massive solar storms hits Earth directly, it can severely disrupt our satellites and global power grids. Fortunately, our beautiful blue planet has a strong, invisible magnetic shield that protects us from the worst of these attacks. Beyond the visible surface lies the solar atmosphere, starting with the thin red chromosphere and extending into the vast corona. The corona is a ghostly white halo of superheated gas that is only visible to us during a total eclipse. Mysteriously, the corona is millions of degrees hotter than the surface below it, a puzzle that still confuses modern scientists. From this fiery corona, a continuous stream of charged particles flows outward, creating what we call the powerful solar wind. This invisible wind blows past all the planets, shaping the protective magnetic bubbles around them and creating beautiful auroral displays. Our sun is more than just a giant ball of burning gas. It is the absolute ruler of our system. Its massive gravitational pull acts like an invisible tether, keeping all 8 planets securely locked in their steady orbital paths. Without this immense gravity, Earth and the other planets would simply wander off into the freezing darkness of interstellar space. But the sun provides much more than just gravity. It is the ultimate source of all life on our planet. Every plant on Earth uses sunlight to create food, forming the fundamental base of the entire global biological food chain. The warmth from our star drives the global weather patterns, evaporating ocean water to create rain that nourishes the land. Without this constant supply of golden light, our vibrant green world would quickly become a dead and frozen rocky wasteland. This brings up a terrifying question. What would actually happen if our sun suddenly disappeared from the universe right now? If the sun vanished this exact second, we would not even notice anything wrong for another 8 long terrifying minutes. Because light takes 8 minutes to travel from the sun to Earth, we would continue living in blissful temporary ignorance. We would still see the bright sun shining in the sky, and we would still feel its warm, comforting gravity. But as soon as those final 8 minutes passed, absolute disaster would strike our beautiful planet with terrifying sudden speed. The sky would instantly turn pitch black. The bright moon and glowing planets would also vanish from the dark night. Without the massive gravity holding us, Earth would suddenly fly out of its orbit, traveling straight into the unknown void. Panic would quickly spread across the globe as humanity plunged into an endless night without any hope of a dawn. Within just a few days, global temperatures would drop drastically, causing the oceans to slowly freeze solid from the top. Most plants would die within weeks due to the complete lack of sunlight, collapsing the entire food chain almost immediately. Only deep ocean creatures living near volcanic vents might survive this frozen apocalypse, completely unaware of the dead world above. Fortunately, the sudden disappearance is completely impossible according to the strict laws of physics that govern our vast, amazing universe. However, our sun will not live forever. Like all living things, stars also have a definitive birth, life, and death. Right now, our sun is comfortably in the middle of its life, steadily burning its vast supply of hydrogen fuel. It has been shining brightly for 4 billion years, and will definitely continue doing so for many billions more today. But eventually, about 5 billion years from now, the sun will completely run out of hydrogen fuel in its core. When this happens, the delicate balance between inward gravity and outward fusion pressure will collapse, changing the star forever completely. The core will shrink and heat up dramatically, while the outer layers will expand outward into the surrounding solar system. Our once stable yellow dwarf star will slowly transform into a monstrously huge and incredibly destructive red giant stellar beast. As it expands, the dying sun will swallow the tiny planet Mercury, vaporizing its rocky surface into nothingness almost instantly. Next, the expanding fiery atmosphere will reach Venus, consuming the hot toxic planet and melting it down to its core. And then, the terrifying red giant will loom large in the sky of our own precious home, the planet Earth. The intense heat will boil our oceans away completely, stripping the atmosphere and leaving Earth as a scorched, lifeless rock. Eventually, the dying sun will shed its outer layers entirely, creating a beautiful expanding cloud of colorful glowing cosmic gas. This glowing cloud is called a planetary nebula, a stunningly beautiful cosmic tombstone marking the death of our great star. At the very center of this colorful nebula, only the small, dense, and incredibly hot core of the sun remains. This glowing stellar corpse is known as a white dwarf, a tiny dense object about the exact size of Earth. The white dwarf will slowly cool down over trillions of years, eventually fading into a dark and cold black dwarf. But long before that distant future arrives, the scattered ashes of our dead sun will float through the vast galaxy. These ashes carry heavy elements forged in the dying star, materials that are absolutely essential for creating brand new worlds. Someday, in a distant corner of the Milky Way, those scattered elements will gather together to form a new nebula. Gravity will pull the dust and gas inward, sparking the glorious birth of a completely new star and planetary system. In this beautiful cosmic cycle, the death of our sun will eventually plant the seeds for new life to emerge. Every atom in your body was once forged inside the burning core of an ancient star that died long ago. We are quite literally made of stardust, deeply and forever connected to the violent and beautiful mechanics of the cosmos. Understanding the sun helps us understand our own origins, reminding us of our tiny but meaningful place in the universe. We have built massive telescopes and launched daring spacecraft to study this blazing sphere of plasma from a safe distance. The Parker Solar Probe, a marvel of human engineering, has actually flown directly through the scorching hot corona of our star. It touches the sun, gathering vital data that helps scientists predict dangerous solar storms before they can strike our planet. Every new discovery reveals just how complex and dynamic our local star truly is beneath its deceptively calm glowing surface. From the crushing depths of the nuclear core to the chaotic magnetic storms of the corona, the sun is amazing. It is a masterclass in extreme physics, demonstrating the raw and terrifying power of nature on a truly cosmic scale. Yet, despite its violent nature, it provides the exact, perfect amount of gentle warmth needed to sustain our fragile lives. We orbit at the exact right distance, a magical region known as the habitable zone, where liquid water can exist. If we were just a little closer, our oceans would boil a little farther, and everything would freeze completely solid. This delicate cosmic balance is a beautiful reminder of how incredibly lucky we are to exist on this blue planet. As we gaze up at the daytime sky, we should always remember the immense, unseen battles raging inside that star. Billions of tons of matter are being crushed and destroyed right now, just to send a single ray of light. That light travels across the empty void, bringing energy, warmth, and the fundamental spark of life to our tiny world. The story of the sun is the story of us, a grand epic of energy transforming into life over millennia. Let us take a moment to appreciate the silent guardian of our solar system, the mighty engine of our existence. Without its relentless nuclear fire, the history of Earth would be nothing but a short and bitterly cold dark tale. Instead, we have a vibrant world, teeming with millions of species, all dancing to the steady rhythm of solar energy. The sun will continue to watch over us, a blazing yellow eye in the deep, dark ocean of empty space. It demands our respect, our scientific curiosity, and our endless wonder as we continue to explore the vast unknown universe. From ancient civilizations worshipping solar gods to modern astronomers analyzing spectral lines, humanity has always been captivated by the sun. We have tracked its movements to create our calendars, relying on its steady seasonal cycles to grow our essential crops. Even today, as we look toward a future of clean energy, We are trying to capture the power of sunlight. Solar panels spread across our rooftops, turning the ancient light from the solar core directly into electricity for our homes. Scientists are even trying to build artificial suns on Earth, using advanced fusion reactors to create limitless clean energy forever. If we can master the secrets of the solar core, we could power our civilization for thousands of generations ahead. The sun holds the key to both our ancient past and our highly advanced technological future in this vast galaxy. As we prepare to leave our home planet and journey to Mars, we will still rely on that familiar light. The immense solar influence extends far beyond the planets, creating a massive protective bubble called the heliosphere around our system. This magnetic bubble shields us from deadly cosmic rays shooting through the dangerous interstellar space of the wider Milky Way. Even at the dark edges of our solar system, billions of miles away, solar gravity still maintains its perfect control. It guides the icy comets of the Oort cloud, ancient frozen relics from the very dawn of our solar system. Occasionally, one of these comets falls inward, growing a beautiful glowing tail as it feels the warmth of the sun. This cosmic dance of gravity and light has been playing out flawlessly for more than 4 billion incredibly long years. We are incredibly fortunate to witness this magnificent, stellar performance during the brief and beautiful span of our human lives. The universe is filled with trillions of other stars, many much larger and significantly brighter than our own humble sun. Some are massive blue giants burning fast and dying young, while others are tiny red dwarfs that live almost forever. But out of all those countless stars in the dark sky, only this specific yellow dwarf is truly our home. It is the only star we know for certain that warms a planet capable of supporting intelligent and curious life. So the next time you feel the warm sunlight on your skin, remember the incredible cosmic journey it took today. From a violent nuclear collision inside a crushing core, to a random walk through a dense and chaotic plasma maze. Bursting from the boiling surface, traveling millions of miles through cold, empty space, just to finally reach your exact location. It is a continuous miracle of physics, a perfect alignment of natural forces that makes our entire existence physically possible. The story of our sun is a powerful reminder of the deep interconnectedness of everything in our vast, beautiful universe. We are born from stars, we live by the light of a star, and our future depends on this star. Thank you for taking this incredible journey through the burning heart of our solar system with us here today, everyone. We hope you never look at the daytime sky the exact same way after learning these amazing cosmic secrets today. This has been another exciting episode of Black Hole Basics. Stay curious, keep looking up, and we will see you